Well, good evening and welcome to Space Oddities. Thank you for joining us this evening. We hope you're all having a wonderful Christmas so far and you're getting all your festive food and drink in and looking forward to the big day. We certainly are. And we hope that everything goes well. And we'd like to wish. No, Daz is shaking his head.
No, no,
You,
no. Grinch.
you miserable curmudgeon. Anyway, ignore Daz. We find that's the best policy always. So anyway, we'd like to wish all our viewers a very, very happy Christmas and in advance a happy New Year. Thank you so much for being with us this year on Space Oddities. It's been quite an eventful year in space, all told. Lots of fantastic astronomical discoveries, lots of amazing space missions. It's been a very full year. SpaceX on target for 100 Falcon launches this year, which they're getting within striking distance of. It's up to 92, I think now, so only a few to go. So it's been very busy. We will, in the new year, do a review of the year, just to remind you what 2023 brought us. So thank you all for being with us this year. It really is much appreciated, and we hope you'll stay with us for 2024 as well, of course. If you're new to Space Oddities here, thank you so much for being here. We hope you'll stay with us. And we'd like to say, obviously, a big thank you to those of you who've bought us coffees to keep the ship rolling. Is that a reasonable metaphor? No. Okay.
Well, keep it from sinking.
Keep it from sinking. That's the one I'm looking for. What's that say on your mug, Daz? Your cup, not your face.
Happy Farters Day. They've crossed out fathers.
Day, right. Okay. All right.
Anybody who knows me, that's true.
Yeah. Okay. Well, we'll veer away from that if you don't mind.
Brussels sprouts. It's Christmas.
Yeah. Especially after last time when we had to fumigate the studio. So, so there we are. We welcome Daz back from his holiday in Lanzarote.
Yes, I'm back.
You had a good time,
be afraid. Daz? Yeah, lovely time.
Good.
Yes, I'm back and be afraid. Just when you thought it was safe to go back in the water, here I am again. Yeah, had a lovely time on holiday. So I've been absent for a couple of weeks, which is unfortunate because when I booked the holiday, we were doing the shows on Monday. Yeah. So I arranged for us to fly out on a Tuesday, and of course, unfortunately, due to circumstances, we've changed the days to Tuesdays.
Yeah.
But I'm back. It's been quite an eventful week. There's been lots of things going on.
Yeah.
But we'll talk about that during the day.
Yeah, we'll talk about that later. Of course, sitting in silence, there's young Roger. How are you, Roger?
Oh, groveling will get you everywhere.
Oh, he's looking good for 18, isn't he?
Yeah, not bad. No.
And the spark for clear skies have returned tonight.
Okay. Well done.
I tell you something. I saw
round of applause.
Round of applause.
Sarcasm.
I saw absolutely fabulous Geminid fireball, which was spectacular. And as usual, I just happened to go outside and look up at the right time. And it started about 70 or 80 degrees above the horizon and went all the way down to the horizon. And
because Roger and myself were talking about it just before the show. It's been quite a spectacular display, even though I've been very restricted with clouds. We've only sort of like had a hole to look through, but luckily that included Orion and the heads of the Gemini to the twins.
Yeah.
So I went outside one night for about 20 minutes and I must have seen at least 10, if not more.
I saw a few.
And then the next night I went out exactly the same, a smaller hole this time to look at. But I saw an absolute massive one go across, and it was so bright and so long that you could actually even see that it was green with your own eyes.
The one that I saw was distinctly green.
Yeah. So it's been.
I'm green colorblind, and even I could see it was green. It was amazing. But I've never seen an actual Geminid firewall before. I've seen plenty of Geminid meteors, but never seen a firewall before. So and we've just marked eight nights of clear skies here. So
excellent.
It's cold though. I mean, it's down to below zero in the mornings. So it's cold. That cold.
But what was it during the day, Andy?
It's been quite cold during the day. Actually, it's been
yeah.
it's gone down to about 19 or 20 during the day. So
I feel
Oh
for you.
dear.
I know, I know, I know. But I actually had to put my winter coat on one morning.
Your big coat
Yeah,
and the vest.
yeah. So there we are. Okay. Anyway, I'm sure our viewers don't want to listen to our chutney, so let's move on. Tonight on the show, Daz is going to carry on telling us about solar storms, and that we're looking forward to hearing about that. And we're going to have a bit of a chat about what's been going on this week. So we'll start in the time-honoured fashion. But before we do, I think what we will do next week, we won't do a show next week because of Christmas. So we will be back on the following Tuesday, which is January the 2nd, I believe.
Will we, if it happens?
If it happens,
Because we were just talking about on the 28th. Now which one is it, Andy? Remind me. SpaceX, is it, with the
Falcon Heavy?
The Falcon Heavy, is that the
And
one?
launching the Space Force hush hush. Nobody knows what
Nobody
it is.
knows
But
anything
it's
about
a space
it.
plane. Yeah. So
Just go on Wikipedia, they'll tell you nothing.
SpaceX are launching their Falcon Heavy with the top secret Space Force space plane on the 28th of December. We haven't got a time for it yet, but if it happens, and it's already been delayed, but if it happens, then we will do our very best to cover it live here on Space Oddities.
Yeah.
So keep your eye on our Facebook page. We'll announce it on our Facebook page if we're doing the coverage. And obviously keep an eye on the channel because we'll create the stream in advance and it will show up in the videos on the channel. It'd be great if you could join us if you're interested in seeing the Falcon Heavy launch. It's always a spectacular launch. And we will look forward to covering it. But there is a little bit of uncertainty about the date because they've had problems with the Falcon Heavy.
Yeah, they've moved it back into the vertical assembly bay for checks because they found some issues with the ground side of the control systems.
Yeah, absolutely.
They've taken it back just as a precaution. But also, we did mention that we might cover the ULA Vulcan launch, which was scheduled for the 24th, 25th, and 26th.
Yeah.
Dependent, but that has now been pushed back to January the 8th.
Yes.
So,
yes, indeed.
So we will try and endeavour to cover these launches, but of course it's dependent on time and whether or not
absolutely
people available.
The best thing you can do, keep your eye on our Facebook page, viewers, where we sort of make all the announcements, and we will keep you up to date there. All right, so no show next week, but we're back on Tuesday, January the 2nd, and if there is the Falcon Heavy launch on the 28th, we will, of course, be covering that if we can, if it means we don't have to get out of bed in the middle of the night. Now, he's the man about which it was once said he does the Sky Guide. So that's all there is to it, really. So, Roger, over to you for the Sky Guide. So what have we got this week lined up?
Well, it's like this. Okay, so leading up to Christmas Day. Da, da, da. So it's first quarter tonight and leading on to a full moon towards Christmas Day. So bully for that. But at 11 o'clock in the evening through this next week, we've got Orion in all its glory in the southern part of the skies, and woohoo! So we've got that, and the full winter circlet, as some people like to call out.
That's a pop word, circlet.
A circlet.
That's
a smaller circle.
Yeah.
It's quite big in the night sky.
That's a Somerset saying, obviously.
Yeah.
Circlet. Yeah. So we've got Jupiter still dominating into the southwest, which is good. And, well, hopefully we'll get to see the benefits of all these lovely winter constellations over the next week or so.
Yeah. Orion has been glorious from here recently. It's been fantastic.
Yeah, it's absolutely amazing. So, but obviously in the early hours of the morning, we'll be seeing that big, bright, shiny Venus coming up through, which is now going into Libra, and then it'll be into Scorpius. So that's still of interest. It's about 57% now, the size. If anyone's still interested in Comet 62P Shushin Sun, it's going through Leo. And on the 26th, there's a very good photo opportunity. That's the magnifications of just over 8, so not too bad with a smallish telescope. It'll be going right by the Leo triplet. So the 28th is a good photo opportunity of a nice comet with the triplet as well. So fingers crossed for any possibility of a clear sky during that period. So you'll be able to catch that from about 3 o'clock onwards for a good opportunity to get a chance with it. So
fingers crossed for that.
See how it goes. So you've still got a couple of hours before twilight, before that opportunity fades. But there we go. But we do have a few images from the James Webb. They've sort of been posting them out like the London buses at the moment. So this is the supernova remnant of Cassiopeia A.
Wonderful. Look at that.
It's amazing.
It's amazingly complex, isn't it?
So we have 4 boxed areas. Number 1 is showing some of the sulfur, oxygen, argon, and neon from one of the stars.
Wow.
And and that is roughly 10 billion miles across.
Nothing. Nothing at all.
Yeah, no.
Just down to the corner shop.
Number 2 is within the green monster, as it's called. And that's ionized gas on there. And more interesting, we've got some other wispy nebula bits and pieces through the whole system. But actually, number 4 is a line of sight effect because it's 170 years beyond where this object is. So it's just a matter of happened to be in the frame for the line of sight. So
it's a very intriguing,
very interesting object.
Yeah.
I wonder what that is.
Yeah, we'll have to have a look into that. But also, have you got any more images on this one, Rog?
I think that might be.
Yeah, that might.
So we've got a comparison between the different cameras there.
But also within the image, they've actually discovered free floating brown dwarf objects, which, and of course, a brown dwarf is a failed star. It's a star. Basically, it's like a big gas giant. A lot bigger than Jupiter, where the pressures inside in the core of these planets has reached just about almost to start nuclear fusion, and in some of them nuclear fusion has started, but it's snuffed out, and it forms what they call a brown dwarf. And they've actually found in these images some of these floating brown dwarfs. Apparently, I thought there was an image of with the brown dwarfs highlighted. Yes, there is one. Yeah.
That will be in this one here, which I thought was in, which is
there
in
it
Perseus.
Is.
But this is in Perseus, not Cassiopeia.
Oh, is it? Oh, I'm reading the wrong one. Right, okay.
It's a different object. Yeah.
Ignore me.
Doesn't that look like?
We'll move on to that.
Doesn't that look like fur?
It does. It looks very sort of like a swept. There's obviously something
blowing it from the left to right. Yeah.
Mind you, those stars in the centre there, if they're newborn stars, they would have that sort of effect, pushing away the gas.
Did I read the catalogue number? Is this IC348? Was that what it was?
Correct.
Yeah.
That is correct. Yes.
Yeah. Okay.
Top of the class.
Thank you.
Yeah,
Okay.
more than me.
Mm. Right.
And so these are the brown dwarfs then.
Those are the calculated brown dwarfs candidates. Yes.
Wow.
And the third image is back to Uranus.
Back to Uranus. Yeah. Yeah, I saw this one. Amazing.
Oh yeah.
This is a wide field which is giving quite a lot of the orbiting moons here.
Yeah, I think these images are absolutely
amazing.
Look at that.
Look at them.
Look how bright the rings are in that.
Yeah,
absolutely.
It's phenomenally bright.
Yeah, there's also, looks like
to the naked eye, these are virtually invisible.
Exactly. I mean,
Absolutely.
also you can see the outer edges of there's still like almost as if there's extra rings forming on the outside, but they're probably actually
I was going to
dissipating.
say that you've got the rings that we already know, but look at the faint rings further out.
Yeah, that's fantastic. It's a lovely image. It really is.
That's a beautiful image. I love the crescent sort of effects on the planet, which of course isn't, but it's a beautiful image of Uranus. Yeah. And Bob, that's Uranus in the infrared, of course.
Yeah,
and where it's very bright, especially the rings. The rings are very bright in the infrared, which indicates heat, of course. Uranus is a very strange world. It's got a heat budget that we don't really understand at the moment. Because it's with Uranus and Neptune, Uranus should be a lot warmer than Neptune because it's much closer, but they're about the same temperature. So there's something going on with Uranus that we just don't understand at the moment.
It's an all round very weird planet. It's something that we need to get some more probes out into the outer solar system to look at these objects and to give us a bit more of an idea of what's actually going on. Because isn't it Uranus the one that's on its side?
Yes, it's tilted at 98 degrees to the vertical.
It's been either hit by something or something's happened. It's at 90 degrees, and it's also got a very strange. So of course everything's tilted upright, so that's why we can see these rings. But then again, of course, we're looking from James Webb's perspective. But this is why these rings are so. I mean, they're almost spot on, aren't they? They really are. There's only a slight elliptic there from a slight angle there. But it's stunning. It's stunning. James Webb, the telescope that keeps giving.
Right. Okay. So we do have a few art images to show again this week. So thank you, one and all. And our first one is a phone picture from Lou.
Oh, nice.
Phone picture, which is Golden Gate and the moon.
Nice, Lou. Thank you.
Well done, Lou.
That's quite a spectacular skyscape, isn't it?
And
Kev's back.
Another one. And Kev's back, yes. He was a bit late in, so I just wondered whether I ought to allow his picture in as he was late.
Oh, I don't know. I think we should. Don't make a habit of it, Kev.
Yeah, rules is rules.
So we've got a combination of some H-alpha on this picture with and it's a 2-panel picture, and this is what he's got.
Oh, Kev.
Yeah,
that's amazing.
We'll let you off being late.
I mean, really, when you think back to Hubble's images of Andromeda, I mean, this is rivaling, if not exceeding, the quality that Hubble was doing back in the late 20s and 30s. Amazing image, Kev. Well done. Absolutely superb.
In fact, we'll probably
using
need more
the
using
the HOs obviously brought out a lot of the sort of the nebula and other details up around the periphery of the absolutely.
Yeah, of course, because
Hubble's been
So we're going to need images like this because, of course, Hubble's been in the news. With because it's all like basically broken down again. It's gyroscope, so I think it's down to its last 3 gyroscopes, which it uses to point in different directions and keep it stable during its imaging cycles. But I understand they have fixed it again. But they are hoping to keep it going until at least 2030, and by then hopefully they reckon that we should have another telescope ready to be launched. And I think it's a Canadian telescope, if I remember right. If you just give me a second, I'll give you the name of it. It's been planned for quite a while, and of course, we got anyway. You carry on, and I'll come back to you with the details on this because I've got.
Just to say that Kevin's integration time was only 2.25 hours.
Wow!
More amazing. Yeah,
that is amazing.
That is right. Onwards for the next one. Oh no, it's another one from Kevin. And you used to blame me for my entries into the gallery as well.
Yeah, but here's a good.
So we've got the ever faithful Orion Nebula. So hasn't tried it for over a year. So this is only 20 minutes before the clouds.
He said he hasn't tried M42 for over a year, so I thought it was about time I had another go. 10 subs in, the clouds descended, so I packed up to watch telly. Wise choice, Kev. Only 20 minutes into this one.
20 minutes is all for that.
Blimey.
And you got the Running Man and everything in there. It's absolutely gorgeous.
Of course. Well done.
And I think you can even actually just pick out the trapezium as well in there.
Yep, it's there.
And I can actually see that as a running man, I think, for the first time.
For the first time, you've actually seen it for the
right.
first time.
Yeah.
Usually to see him, you need to turn him by sort of like, so he's up at the top.
Yeah.
But yeah, you can see the running man. He seems to be running.
I tell you what, Kev, you're getting the hang of this, aren't you?
Yeah.
Well, I was told once before that the running man, it also looks like a pigeon flying away.
Yeah, I see that as well.
With his head on the left.
Yeah.
Yeah, it could be. That's very well.
Well done, Kev. I've never actually visualised that as a running man before. I've never seen it, but I can see it in your image. That's amazing. So thank you.
That's gorgeous. Yeah. Just going back to what I was talking about, the telescope that they hope to be launching in 2029 with ultraviolet capabilities like the Hubble is called Castor.
That's right.
It's a Canadian telescope that they hope to be launching before we actually do lose the Hubble. I mean, the Hubble's what, 40? How many years? 40 odd years old is that?
No, it's 1991, wasn't it?
1991. Oh, I don't know. I'm probably thinking of something else. Oh, I'm thinking of Voyager because that's going to be. We'll talk about that later.
Okay. Yeah. Right. Okay. So another regular from Jerry, which is the Fossil Footprint Nebula in Perseus. I'm not sure about that one. Don't know if I was aware of that one, but this is what we go.
Because I think it's in the southern hemisphere. There's the cat paw nebula, isn't there? And
it
looks
so I suppose
like a cat's paw thing. But this definitely looks like possibly a T-Rex. A Mark Bolan footprint.
Or it could be a Freddy Krueger glove.
Yeah.
Nightmare on Elm Street.
Well, do you know what it reminds me of? A Fry's Turkish Delight wrapper.
Oh, yeah, the colours, yeah.
Okay.
Lovely image, Kev, anyway. Thank you.
Well done.
Yeah, well done.
Oh, God,
it was this
Oh, no.
No.
This is what it was like at 5 o'clock this evening.
Yeah.
God.
Yeah,
so the Lunar V and X should be quite nicely on view now. So get out there and have a look.
Yeah, they should have.
But after the show, preferably.
Yeah, but because we were talking and just before we come on, and I said, even here, the moon looks really spectacular. We got a clear sky for a change. But I bet once we finished, it'll all be clouded over. But yeah, it was a beautiful moon. So that's well done, Rog. That's a lovely image.
Okay.
Yeah, that's great.
That concludes
I thought you were going to say that was one of
for
yours
20.
as well.
Yeah.
No. This is an AI by Adobe Firefly. So one that I typed in, and this is what came out the other end.
That's really good, isn't it?
Yeah.
Is that the new Glen there?
Oh, probably.
Yeah. Is that the only way they're going to get to launch it?
I expect so.
That's definitely the Blue Origin spacesuit as well that he's wearing.
Yeah.
Yeah.
Oh, a little message there. Thank you all for the wonderful images that you've all sent in, and see you in 2024.
Yeah. Thank you viewers so much for sending all your images. We still want to do a sort of a best of photo book. We'll think about that in the new year, because the images you've sent us this year, they've just been, what's the word I'm looking for, guys? Stunning, I guess. Unbelievable.
Stunning, yes.
Stunning. So we thank you very much for them.
All the words of
and
just don't put a calendar date in there.
No, absolutely not.
Was that a dig, Rog? Was that a dig?
I'll shut up. Yeah.
Yeah. So there we are. So we will think about that in the new year.
Okay.
So there we are. So that's it, Rog.
Okay.
Okay. Now, while we're on the
last
subject,
gallery of the year.
Thank you, and thank you for doing it.
Yes, thanks, Rog, and Rachel for all their hard work.
Yeah, Rog and Rachel this year, between them, have produced the gallery every week. So well done both, and thank you very much. Rachel, unfortunately, was unable to join us tonight, as she's incredibly drunk on vodka again. So,
she wishes.
Yeah, she wishes. Yeah. But anyway, just staying with the outer solar system for a moment. I don't know whether you saw this in the news, but there have been some incredible discoveries at Enceladus, and this is analysing the material from Cassini. If you remember the much missed NASA space probe Cassini was able to dive through the plumes of Enceladus not once but a few times. A new analysis of that material shows that there are a lot of all complex organic compounds that they hadn't seen before. Things like ethane and methane, but lots of other things as well in those plumes. And this is highly indicative of a chemical engine with great vigor inside the little moon of Saturn. And scientists are even keener now to go back to Enceladus because it's looking more and more like an ideal environment where life could get started in the subterranean ocean under the ice of Enceladus. And these new organic compounds they found, I just need to say this again because, it just needs saying. When we talk about organic compounds, we're not talking about life, because organic chemistry simply means any chemistry involving carbon. So these are all obviously carbon-based chemicals like ethane and methane, but some more complex ones have surfaced, and there's definitely some sort of a very powerful energy source under the ice of Enceladus. So it's very much, if you like, an analogy might be the black smokers on the mid-Atlantic ridge, where it's thought could be one of the environments where life on this planet got started, because if you've seen the black smokers, you've got boiling hot water, incredibly toxic environment, and yet around those black smokers, an ecosystem has grown up which thrives on that toxic environment. And it's pretty sure that there's something similar at the bottom of the subterranean ocean on Enceladus. And the energy source is going to be, again, the moon being stretched and squeezed by the gravity of Saturn. And, we desperately need a mission to go back to the moons of the outer solar system. And whether we'll see it again in our lifetime, I'm doubtful. Well, my lifetime anyway. You youngsters out there, you probably might see it, but in my lifetime, I think it's doubtful. But there's a lot going on in the outer solar system. It's where all the action is in the solar system, really. So I hope we can get back there soon. Okay, guys, anything else has taken your fancy in the news this week?
Well, there's been, like I said, I've got 2 weeks to catch up on. But there was one I saw that I thought gave me a bit of a giggle, if I can find it. And it's a snack food company in America, apparently having run out of humans to sell to, is now marketing to aliens. MoonPie kicked off a new campaign recently that features ads written in Linkos, a language developed in the 1960s for extraterrestrial communication. The ads displayed in various locations worldwide are not meant to be read by humans, the company claims. I genuinely, spokesman said, I genuinely believe there are aliens, and I think if you were to market to them, this is the way you should go, said Jeff Benjamin. I don't know what he's been smoking. Chief Creative Officer for Tom Brass. The ad firm said that who created the ads. That's where Jeff Benjamin's from. He said the company has not yet reported any uptick in sales. So that made me laugh. But they thought
Well,
they,
it could only happen in America, couldn't it?
well, it did make me giggle.
Where
I thought, although
99% of the lunacy in the world
if
comes from.
yeah, if you're that desperate,
Mm.
of course, today earlier on, Blue Origins launched their new Glen. This is
Yes.
a 15-month hold since their last bit of a disaster when they flew. Luckily, it was an unmanned mission. At the time, it was for a scientific
Yeah,
experiment.
there were 33 payloads on it, apparently.
Yeah, and some of it was a load of postcards. I don't know what they're going to do with those. But I suppose just to say they've been into space, they've been above the Kármán line, debatable. But yeah, it says it launched and everything went well this time. They were unsure whether they would launch today because up until just recently, the FAA hadn't issued a certificate for them to be able to fly. But whether or not this certificate also means that now they can start human adventures for the rich and famous, I do not know. This
No,
could have been just
no, they haven't said. They haven't
to
said.
cover this one
Mm.
issue. So yeah, there was that happened today.
Also, can I just mention before I forget? The European Space Agency this week shipped the first 18 of the mirror segments for the ELT telescope, the extremely large telescope, which will be the world's biggest optical telescope, currently under construction in Chile. The first 18 mirror segments of the main mirror have been shipped to Chile. There are 798 segments of the main mirror, and they've shipped the first 18. So you know what I'm going to say now. I think they need a bigger boat. Yeah, they need a bigger boat. If they're only shipping 18 at a time, and there are 800 of them, it's going to take them a while. So they definitely need a bigger boat. So that's good news. Construction of the world's largest telescope with that 39-meter mirror in the Atacama Desert in Chile progresses. First light of the new telescope, which will be the most powerful telescope the world has ever seen. First light is expected in the year 2028, and it was delayed a couple of years because, not surprisingly, of COVID. So there we are. Anything else, Roger? You seen anything that caught your fancy in the news?
Not that I've nothing that is worth mentioning.
Nothing outrageous. No.
No.
Okay. Right. Well, in which case, we're going to go over to Daz if he is ready.
Yeah, I'm just making a note. It's actually to do with what we're just going to talk about now.
Oh, okay.
Yeah. Yes. Right. Let me just get my thing out. Now, as you know, this epic of mine about solar storms is been going on a little while, but I will finish it one day. But I would like to say I can finish it today. But if we'd probably overrun by hours. So what I'm going to do is I'm just going to do the next part of this, which will actually take us into what we can expect or what we've experienced in the past with solar storms. But I will stop at some point, and I'll tell you for why when we get there. And then I'll produce another thing. And hopefully, what we will do is, if you want to listen to the previous uh, episodes of this epic, it's like War and Peace. Then if you go back through the shows, you'll find them in there. And it's basically starting from the Carrington event, which I'll mention in a little while, just in a bit of a sort of like a prelude to go in. But I'm not going to go back into depth about what I've talked about before. We're just going to now talk about what happens, especially when these solar storms launch from the sun towards Earth and onward. So what I'll do is I'll just get my thing up, if you'll bear with me. Right, now I'd like to start this. I hope everyone can see that. I hope you can,
Yeah,
you can see. That's fine. That's fine. Right, I'd just like to put this one up, and I'm going to ask everyone which one of these images is correct. There is a reason for it, because it depends upon which one you're looking at as to how these solar storms, when they hit our magnetosphere, how it will react with the Earth. One of them's correct and one of them's wrong. I'll let you think about that for a little while. We will be coming back to this a little bit later on, and you'll see why. So, okay then, let me continue. Right. So I'll just give a quick recap. As I said, I mentioned the Carrington event. The gentleman with the beard who on the 25th will be delivering presents. He will, that is Lord Carrington. He was observing the sun on a certain date that I hope I've forgotten. And he was observing some sunspots. And while he was actually watching them, there was also another chap as well, who was observing the same sunspots, but from a different location in the UK. But Lord Carrington, he suddenly saw there was a very bright flash. And it's what we would call now these days a white light solar flare. It's the first time it was ever seen through a telescope. And these solar flares that I'm talking about, you can come in two flavors. You get white light solar flares, you get red light solar flares. The red ones sometimes go undetected, and they're called sort of like they're sneaky solar storms that will hit us. Excuse me. Now these solar flares, they create a lot of X-rays, and of course X-rays are part of the electromagnetic spectrum, so they're light. And so when you actually the first we will actually see, and if you look on the top right, you'll see a magnetometer trace from Q that was done at the same time as when he was viewing the actual sunspots. And the drawing in the middle is a drawing that he did at the time. And as you can see, it comes along. Then you'll see on the bottom trace a massive spike. That's what they call a magnetic crochet. And it coincided with what happened, what Carrington actually saw through his lens, because the X-rays are traveling at the speed of light, and that's the first we will see of it. And it's the start of a sort of like a magnetic storm, which can last for will only last a couple of hours. But this time they wouldn't have known much about it, because where the Space Oddities, unfortunately, where the Space Oddities sign is, you'll see that the actual traces go off scale, and that's when the main part of this sort of like a magnetic storm will actually hit. And although they wouldn't have known it at the time, they that would have interfered with, or would have probably cancelled out all radio communications, and could possibly have sort of like started it damaging satellites if we had them in that time. Because I think the date is 1859, or I think some rings a bell. 1859 or whatever. Yeah. But what the reason it became more notorious was the fact, if you look at below on the right, there is a telegraph machine. and the telegraph had just become very, very popular, and they had built up quite a network of telegraph cables all over America. And what was happening, and what they found was that the the actual cables were being overloaded, and by the currents, the radiation that was hitting the ground was inducing a current in the Earth's mantle, which had nowhere to go. So it was looking for a way out. So it induced currents in the cables. And what happened is the telegraph network. In fact, it worked better. They had to. The telegraph network at the time was run by batteries because they had no electrical network. So they disconnected the batteries, but they were still able for 2 or 3 hours to use the telegraph. But some of the machines, but it was unstable, and it would spike, and you'd get sparks, and it would set light to the ticker tape, as you can see on the top there. They were easily put out, and probably such a few burnt hands where people smacking out, spanking out the fires. And of course, we had fantastic aurora. Now, the aurora on this occasion, I think, went down to as far as towards the equator, down to as far as 21 degrees. So it was just in fact, if we had cameras that we've got now, you probably would have seen the aurora at the equator. Now, this is the benchmark that all solar storms since are marked against. They back engineered all the information that they did have, and of course they didn't have much. They only had magnetometers, and they've used the information we've gathered over the years and the knowledge we've gathered, and they've re-engineered and back engineered it, and they've got some idea of what this actually was. Now, so right, let's go. I'm using my cursor again to point things around. Now, as we know, the sun is multi-layered. At the core, you've got the nuclear fusion going on, and then this energy is radiated and radiated and convection moves out towards the sun's surface, the photosphere. Now, all this turmoil causes different events, and then, of course, then around the actual photosphere, you got the corona, then you got the coronasphere, which is we can only visualize these during total eclipses. Right. Now, there are 4 phenomena on the sun that actually create space weather, which gives us problems. And you've got solar flares, coronal mass ejections, coronal holes, and solar radiation. Now, these usually, when we've got an active sun region, we usually you can see them with visual light because they usually got sunspots on them, or you will see them as plages if you're using H2 filters. And these are the active regions where all the magnetism's getting all wound up and things like that. Now, from the sunspots, you get magnetic lines protrude out through the surface of the sun. They get twisted and tortured. They snap and they produce what we call a solar flare. It's a very bright spot that you can see on the top left. Now, next to it on the top, you've got a coronal mass ejection. Now, these are events where the magnetic lines are actually not just joining sunspots, but they can actually join active regions, magnetic regions, active areas. So they can be very long, and some of them you can see they'll cover 2/3 of the sun's surface. They're usually just a dark line. Now, these again, they're being tortured, the lines are being twisted and everything. They too can erupt. And this time because they've picked up, they're absolutely full of the sun's plasma, which is what the sun's actually made of, and other energetic particles, which it will throw out into space. And this will travel through space as a solar storm. And they can either be associated with the solar flares. If they happen together, they will give each other a big boost. Coronal black holes They are where areas of the sun which has very little magnetic interaction going on. You can see the bright spots, you can see the sun's surface and all that, but you can see this dark hole in the bottom left-hand corner. That is, but at the top you can see, virtually covering almost most of the northern hemisphere, this big dark spot. Now it's not actually a hole; it's just where there's less magnetic interaction going on, which is so it's basically, it means that the solar the energetic particles and that can actually pass through into the sun's atmosphere and then out into space. And because this is happening, that area is cooler, because in the more active regions, all the energy is being trapped in the magnetic lines that's been held a prisoner, so it's ultra hot. But where there's very little activity, the sun's temperature has dropped, so we see a dark spot due to the wavelength that we're looking at this in. And then, of course, if all of these happen, and if all three of these coincide, a solar flare, coronal mass ejection, a coronal hole, then we could be in for a very big storm if it's Earth directed. And within that solar storm, will arrive to us as a geomagnetic storm, because when you get a coronal mass ejection, as in the last image on the bottom, you will get a lot of very high energetic particles flowing through space. And this is a picture from, I think it's Soho, one of our sun monitoring telescopes, and it's the actual sensors have been blanked out by the radiation. You can see all that those white specks and everything there. So that's what we've got coming towards us. Now, usually when we get a very big solar storm, if we just go look at this. So basically what we need to look at is that if you look at the sun as a whole, if it's a quiet sun, we just get the solar wind, which is high speed streamers, and in some interplanetary shock waves if we get a coronal hole pointed towards us. An active sun will get solar flares, which is a release of X-rays and radio bursts traveling at the speed of light. SEP storms, which are solar energetic particles. This is sort of like the radiation that will be enhanced in any sort of solar flare. Now, usually, as I said, the first thing we'll know within 8 minutes of the event happening on the sun, we'll see the X-rays arrive, because we'll see the light arrive, the brightening of the spot. And that will give us our first indication. And then usually between an hour or 2 hours later, you will get a radio blackout or radio interference, depending upon how much radiation is caught up inside that and magnetism in there. And you'll also get, with an active sun, coronal mass ejections, which is massive amounts of solar plasma and enhanced magnetic fields that drive strong shock waves in space. They're slow moving and they travel to Earth. Usually takes 2 to 5 days. And they can cause geomagnetic storms. Now, as I said, if all three happen together, these events can arrive very, very quickly. They can arrive within 14 hours, I think, is the fastest one that has arrived to us, and that caused us a lot of problems at the time. So that's what we're looking at. Now, as I said, the sun is like an onion. So to see all these different events, we need to look at it in all of it, the electromagnetic spectrum. So all these images here are all of the same event, taken all at the same time, and they are showing. The colors are added afterwards. So you always get sort of like a black and white image with most of these wavelengths. And then the color is added afterwards, basically to distinguish the wavelength that they've been taken at. But as you look through them, we're going from a Dopplergram to a magnetogram, and then we go all the way up to 131 Armstrongs. That's how these wavelengths are measured. But you can see each one looks different. And remember, these were all taken at the same time, but we actually see different parts of or different slices of the onion, if you understand what I mean. Because all these different layers, produce the events that happen in them produce different energies, different temperatures. So to see them, all of them, we need to look at them through all these different wavelengths. And you can see there, and I think you can just see underneath if you look closely, it'll tell you what each wavelength, what it will give you an enhancement. And what they will do is they will combine these images to give you a stacked image, and then they can pick out so you've got all the things together to see a perfectly active sun. So this is why we look at it in different wavelengths, and that's why sometimes you see the pictures of the sun are different colors. Right. So this is a CME, as we call it, a coronal mass ejection. Now, this one, luckily, there's two there. You will see that that's actually pointing off to what to us would be the west. That means it's not directed at us, but because it's so large, it will cause disturbance all around the sun. And as it spreads out into space, there is a form to these storm waves, which is full of magnetism, magnetic lines, which has got all the energy and the radiation trapped within it. But it will spread out like a bow wave on a boat, and we can catch the edge of some of this. And the bigger it is, the bigger the event, the more we will actually feel we will feel some benefit from it. Again, this is another one which showing. Now, these are all the bright spots you can see in the north and south hemispheres. That's the active regions I was on about, and you can actually start to see at this wavelength some of the the magnetic lines coming off it, and also you can see some dark stripes running diagonally across in the northern hemisphere. That is what I was talking about, a large filament, and when these erupt, they send hundreds and hundreds of tons of material out into space. But you can see at the 9 o'clock image, you can see these big loops of these prominences as well. That's the magnetic lines, which are full of energetic particles, and that could break and then throw some more stuff off into space. So what we got next? Again, here's another chronograph image. Now this is from the Helio Viewer. Now this is an app that it's free. If you go on it, you can actually go back and watch the sun in real time. You can also produce videos, which I do quite often. You can either have it looking at the sun in the middle, or you can have it here. This is from Soho, and it's got two coronagraphs on there, different distances or different sizes. And usually what's happening is the idea of a coronagraph is it actually blocks out the sun. This has been combined so you can see the sun in the center. And then what you can see, and it's like a total eclipse, you can see what's happening in the coronosphere. You can see these stripes off to the north and to the south west, which are solar winds, which are being blown out. Where it's very light, it's probably where there's a coronal hole blowing even more energy. But where you see the loop at the 9 o'clock position, that is a CME erupting. And they use the coronagraph to gauge the speed at which this is moving away from the actual sun itself. I'm sorry if I'm repeating myself, but I did swear I wouldn't. This is a NOAA prediction. When a storm has happened, they will take all the information they've got, and they can produce these images. It is actually a movie, and you can actually watch it yourself. But what you've got is you've got these circles in each image. There's 4 images here. You can see the time at the top and the date, and it will give us a prediction of when these things and how they're going to hit us. If you look at the say let's just go to the top left. You've got two circles, one above each other. The top one is looking down from the sun, from the North Pole. So you're looking down onto the North Pole, out through to the South Pole at the bottom. And then on to the right of it, you've got this fan shape. Now the sun is marked as the yellow ball, and then you'll see a little green ball, which is the Earth. The other balls you'll see around the Earth are usually the satellite positions, where they actually are the ones gathering this information for us. So as you can see on the top left, there's a solar storm on its way. It's moving out towards Earth. That storm firstly go to the right of that one. You can see the storm's just about kissing the Earth. Then other storms have erupted in the meantime. If you come to bottom left, and they are also moving out towards us, and you can see they're catching up with each other, and it tells us how fast these things are moving. And sorry, I forgot to say that the lower circle is the speed of the solar winds, and the direction, and the fan will give us both of them will give us the direction. The fan as well as the circle will give us the direction that these solar winds are traveling. But as you can see, if you follow all the way through, eventually there's a big solar wind. If you see the red sort of like fan coming off a curled fan, that is a coronal hole, which is also blowing these things faster towards us. And in the last image on the bottom right, you can see these storms have hit us. And if you look to the right, there's a grid, and it will show you along the bottom. It's got the date and time, and it will show you what time they expect it to hit us. And to be quite honest, they're getting pretty good at this. So if you can go to NOAA, that's the North American weather agency, but they also do space weather. And you go to NOAA space weather dashboard. Put that in, and you will get a big page which has got loads of information, and you'll see these types of things on there. And you can actually watch the video of how these storms are going to run, but they are getting pretty accurate. And if you've got an Aurora alerts app on your phone, keep an eye out when you see these things. But it's all there, all the information you need. So we will get some warning. Now, as I said, solar flares, they arrive within 8 minutes, and they only last a couple of hours. These solar storms can last days, because if you get 2 or 3 of them come through, and they all start to bank up on each other, because the latter ones are moving faster, then they will last a stage. And you will also see on the graph on the right, you'll probably see peaks of when each one will hit us if they haven't caught up each other. So you'll see sort of like a jagged line there. So I hope I'm not waffling too much. Now we're back to this image. The image on the left is wrong. That is not the Earth's magnetic field. It does not all generate from the North and South Pole. You can see it when you've got a bar magnet and you put a piece of paper over it, sprinkle some iron filings on it. They don't come from the North and South Poles. The image on the right is correct. Now, the reason I say that is because the way this is configured, it affects how, when a solar storm hits us, how it will affect us. This is our magnetosphere, which protects us from all the deadly radiation, and it does a wonderful job, trust me. So here is an image of a solar flare and a coronal mass ejection. The flare is the bright spot, and the coronal mass ejection, because like I said, if these things happen together, they give themselves far more oomph. And if there's coronal black hole, that will give us enhanced solar winds that will push it even faster. Now, when we get a solar storm, usually they don't happen as one single event. They can happen over 2 or 3 days, where you'll get smaller flares, you get smaller coronal mass ejections, which aren't of any significance, but they will be moving out into the interplanetary space, and what they will actually do is they will move out, and they will start to clear anything that's in front of the major storm. And what will also will happen is it will actually start to, how can I say, ring like a bell, our magnetosphere. It will disrupt. They will start to disrupt the magnetosphere. Now, what will happen is this big storm is going to be very, very fast. It will rush out. It will mop up. Now, I've said this before. They do not merge. They all bank up, and the ones that are previous will slightly slow down the initial one, the big storm. But what they will do is they will all they will all catch up with each other, and that will give the storm more energy and more duration when it actually hits us. Now you can see here with the Earth, you can see the Earth here. Now you can see what's happened here is that on the sun side, the magnetic lines have on the sun side. Well, we've got the Helios sheath, this light blue, the light blue dome that's on the side of the sun, which you can see the solar wind crashing into. That's the solar sheath. That's the start of our magnetosphere. But as you can see, some of the solar wind and everything else has got through, and it started to squash the magnetic lines together. And in fact, if you look at north and south, you'll see some lines have started to move to what I would to say the left side, but they've actually broken and they've peeled back like a banana skin. Now these will reconnect far to the right, and we will get a very big teardrop shape. And these will be basically it just means that more solar radiation will reach the magnetic lines that are closer to Earth. And of course, the more of these that peel back, the means more and more radiation will get through to the Earth, giving us our solar storm. But also, these lines that have been swept back will be also channeling a lot of the radiation and the energetic particles back from that have passed the Earth back down into the North and South Pole and create glorious aurora. And depending upon how much radiation is inside this actual solar storm will depend upon how big the aurora is, basically how far south or north it will move. And like I said, with the big storms, if you're on the equator, you point your camera north or south, you will probably see aurora on the big events. But that's only with cameras. You wouldn't see it by eye at the moment. So that's basically what's happening. The CME and the storm has moved towards us. It's peeled back some of our magnetic lines, but it's held it and it keeps so all the radiation away. Let's put it this way: we have survived so many of these events, which we'll talk about in a little while, that it does a wonderful job. It keeps us safe. Keeps us safe. Some of the panic stuff you hear about is exactly that. It's just waffle. So I hope that you understand that. So anyway, how would a Carrington type event affect Earth today? Now, bearing in mind, like I said, with the Carrington event, the most obvious thing that it affected was the latest technology. Then was the telegraph lines. Well, of course, since then we've moved on. We've got satellites. We've got electrical networks all over the world. We've got we've got the internet. We've got everything that possibly could be affected, and it will be, but not to the effect that the doomsayers are worried about. So, just to give you an idea, these were two. On this sun disk, you can see two sets of sunspots. They're two groups, and the top ones are the ones that are drawn in are the Carrington event, and the other two groups, the dark reddish, well, with the red rings around them, they are from 2003. And if you can see, these sunspots are of all equal proportion. Now, these 2003 were what they were called, if I remember rightly, the Halloween storms. And we'll talk about these later. But you can see how much of these sunspots, how big these regions are. And one thing I will say is that I didn't mention before, you're looking at a disk. two-dimensionally. The sun is not two-dimensional. It's a sphere. Now, what I mean by that is if an event happened on these spots, as you can see, the Carrington spot is almost dead center. It's not quite, but that means if that had been dead center, we would have a solar storm pointed directly at us. So that some people call it a sniper shot. It's dead, it'll nail us dead in the middle, and we will get the full force of it. But because it's a sphere and it's slightly off angle, the same with the one in the north and the one in the south. If any events happen there, they will go off in a northerly or a southerly direction. And of course, if they're east to west, they can either go off to the northwest, the southwest, or the southeast, southwest. So, for us to be concerned about is anything that happens dead center of this disk. But so that's it. And as I said, the AR486 was from the 2003 Halloween event, which we'll talk about at some other time. So what we got next? So to measure a solar storm, we have 4 things that we look at. And what I've got here is I've got a table, a list of what we actually look at, measurable effects of solar storms. Now, on the right-hand side, you will see some dates. Now, these are the storms that have hit us, but as you notice, none of them are the same. They're all different dates, and that's because we've never had a storm take top prize in everything. So what we do, got sudden ionophonic disturbance. That's X-rays from solar flares. So you're talking about radio interference. We can measure that. We can measure the crochets from the magnetometers. And again, as I said before, because you can see 1859, sorry, was the Carrington event. And you'll see that only came top in solar energetic particles. So we're talking about sort of like radiation and things like that held within these magnetic lines of these storms. So the X-rays, the biggest X-rays were on the 4th of November 2003. So again, that was one of the Halloween ones. Solar energetic particles was deemed to be the Carrington event, although they back engineering other storms, they think that actually ties for first in there. But we'll just stick with Carrington. We'll give him his due there. The speed of the solar wind, as you see, the biggest for that were 1972, and again we'll talk about that in a while. Well, at a later date. The magnetic storm, which is within involved in everything, so that's going to cause havoc with our atmosphere and our magnetic lines and our magnetosphere, and of course aurora, who had the biggest aurora. And as you can see, there is not one date is repeated in any of these. It's because every single event is different. And the only reason we use the Carrington event, the 1859 event, is because it scored the highest. In fact, it made the podium, gold, silver, or bronze in all of these categories. But all of these others here, you can see it was beaten by all these other dates for what was actually in the storm itself, and possibly some of these didn't even make silver and or bronze in the solar energetic particle thing. So they're all different. These things are all different. And if you look for the magnetic storm, that tied for 1989 and 1941. So yes, they all what we can measure and what we can glean from these storms, back engineering old ones and things like that. And they think that for some of these storms, like the Carrington event, they underestimated, so they could be bigger than what we actually thought. But that's how we measure them. It's these 5 things here. And the most obvious is the aurora, and that's how most of the older ones were seen by people from the long distance past. So, oh, I've got all this writing in the way. So what have we got? So how has the event affected how many view the how people view the Carrington event? Both in the press and online, we find these events described in doom and gloom. Carrington-like events they seem to describe them as mega flares, kill shots, or micronova. Some people describe it as Armageddon from the sun or the wrath of God. Power grid killers, basically any space event that will spell doomsday for the Earth, weakening magnetic field, and to all the electronics on Earth. Well, we've had them before, and none of these things have happened. Electronics were burst into flames. No. Buildings were burned down. Only if you're careless. The Carrington event will kick us back into the Dark Ages, and the radiation will be lethal to all on Earth. That's all rubbish. This is Hollywood thing. This is what you'll see in the disaster films. And because we've survived many Carrington type events, and we're still here, so there's no way that this is going to event. But that doesn't mean we shouldn't be concerned. So here we go again. So like I said, people think their house is going to burn down. If you look on the top right, this was from Quebec in 1989 when a storm hit us, and some of the transformers basically had a cascade of a failure cascade effect, which overheated some transformers and melted them. People think the lights are going to go out and they're not going to come back on. We'll be back in the Dark Ages, literally, and power lines will be bursting into flames and things again. This is all hyped up thing. We do have to take precautions, but we'd have to have a very, very, very large and a very long timed event for any of this to actually become anywhere near true. Because we can control a lot of these matters now. Since the 1970s, when we got space assets, this is when we've really been able to discover and improve our knowledge of the sun and the activity on the sun, how it's going to affect us here. And we're still working towards it. I mean, these transformers that melted, they were all oil filled. The oil basically boiled and all turned to super steam, and so they melted. Well, now that a lot of countries are going over to dry transformers, so that can't happen again. With the cascade of failure effect, they've learned that what they must do is, this is where we must learn what these things are with space weather, is that we must alert the public to turn off everything that they can, reduce the power in the power lines. And also what we have to do is disable all the trip switches, because if once you start getting trip switches go off, this will add to the cascade effect, forcing more power down the lines that is induced by these solar storms in the power lines. It will force it into other transformers, and this will cause a cascade effect, and you run out. The power systems, if we reduce the power in them, can survive the increased power induced in the cables for quite a long time. But if they arrive over days, several days, and they carry on, then we could have problems then. But instant death and things like that is totally incorrect. So why should we be wary? Radio blackouts. Now, we get these now all the time, and these start with the solar flares. As soon as they hit, an hour or so later, you will get some sort of radio disruption. And the bigger storms would usually it starts with these low wavelengths, but with the bigger storms, it will go all the way to the high frequency radio waves, and you'll lose all communication. And this, of course, then affects emergency services, communication with drones and radios and everything. GPS, that's another one. Now, this is satellite based. If you've got disruption to your communication systems, you're not going to have any GPS. You'll get boats going around in the mid-Atlantic, going around in circles because they don't know where they are. And if you use GPS, it doesn't. What it does, it doesn't actually take the GPS out. It alters where it thinks you are by moving with what happens in the atmosphere and the magnetosphere. With any changes in there, it will think you are somewhere else. So you've got problems there. Satellite internet outages. Well, of course, we've got the World Wide Web. If the satellites, if they have to shut down the satellites to protect them, I mean, satellites can be protected. That's something we have learned. And new satellites should carry the protection to protect them from high solar energy from these storms. But of course, that only means that they can be protected on one side. But then, of course, when there isn't a solar storm and the sun's not active, the sun's heliosphere shrinks, and then we get problems with gamma rays from outside the solar system. Again, like I said, low Earth satellites would need protecting. We saw this with a solar storm back in 2000 what was it, 2021, was it, when the SpaceX lost a load of satellites because the Earth's atmosphere expanded and the drag caused them not to get into their proper orbit. Medical services, again, they rely upon communications. Aviation, radiation exposure over the North and South Pole. If you've got a lot of radiation coming in from a solar storm, giving us lovely aurora, it can cause us serious radiation exposure if you're flying over or anywhere near the South or North Pole. Power network outages, again, if they're big. And of course, then we've got space colonization and tourism. If people are in space, you've got to be able to protect them because out there you haven't got the magnetosphere to protect you. Right, I'll just quickly go through this. What I'll do is I'll stop there because that's what we're looking at. And as you can see, we got records of solar events all the way back to 5410 BCE, and we get these from ice cores and for tree ring analysis. I'm going to stop there because I'm waffling on a little bit. I went on a bit more than I should do, and then we will start to look through these at a later date when we've got some more time, and then we'll hopefully bring it up to the present day. And because once you get to sort of like in the 60s, that's when we really began to understand what was happening and how these events could be quite serious. So I'll stop it there. I hope I didn't bore you too much. And we will look at the good stuff, the exciting stuff, how these things have evolved with us over the years up until to the present day. Sorry if I waffled. I can't hear you, Andy. You're muted, Andy.
Yes, I am. Yeah, thank you, Daz, for that wonderful look at the sun. Really, really interesting, and something we take for granted, yet we don't really ever appreciate how dangerous it is, and how lucky we are to have a magnetosphere, basically. So,
there are some questions I've just noticed that have come up. There's Ian says funny looking piano at the bottom. I take it you're referring to the telegraph thing. Magnetic reconnection sparking. Can we see solar flares as such? If you now, one thing I'm going to say to you all: never look at the sun with the naked eye or through a telescope or anything without the proper protection that is designed to do the job. So, yes, we can see the solar flares. The best way to see them is, like I said, I can what I'm doing at the moment, I'm doing another basics. And at the end of there, I will put you loads of resources that you can go and look at, and you can see these solar flares without having to look at them with your eyes. Helio Viewer is a fantastic one. And also there's on YouTube, Ian looking through an onion glass. How do you spell Noah? Oh, sorry, Noah is Noaa. Noaa. Oh, so Kevin answered that for me.
Kev
Thank you. Thanks,
right,
Kev. And it's like I said, if you want to have a look at their space weather predictions, you just put in noaa.gov /space weather dashboard, and that will bring you straight to it. And then you've got all the information there. It gives you videos and everything. This does look quite serious. Well, yes, it does look quite serious, but don't think of the doom and gloom and the end of the earth scenarios. For that to happen, then we've really got to. It's got to be absolutely probably a supernova. So it's. I mean, they are very, very serious, and they will cause us a lot of problems. The more we rely upon technology, the more problems we're going to have as they come along.
And
but
the more we can study the sun, the more able we'll be to predict these events.
I mean, they're trying to get the position where space weather is broadcast on television as terrestrial weather is.
Absolutely.
But it's just as unpredictable.
But I mean, many years ago, the BBC told me seriously they were thinking about including clear sky forecasts on their weather forecasts.
Yeah, it
and that happened either. So I wouldn't hold your breath on that one.
All the
just before we finish, a couple of things before we finish, just looking at space launches that are upcoming. On the 22nd of December, we've got a SpaceX Falcon 9 launching 2 German military satellites. On December the 22nd or 23rd, we've got a Falcon 9 launching another second generation batch of the Starlink V2 mini satellites. Now, that launch is notable because it will include 8 new satellites that will give give you direct to your phone transmissions. So your phone will be able to connect directly to satellites, and you won't need any special sort of phone. Your existing phones are capable of connecting to the SpaceX Starlink network. SpaceX have partnered with T-Mobile in the US to bring this service to customers in 2024. And they are having negotiations with companies in Europe to take it up as well. And it's seen very much as an emergency facility in case of problems, in case all your local cell towers go down. And the way it works is that your phone will try to connect to its normal towers, and if it can't, it will automatically connect to the Starlink satellites. This will be fantastic in areas of the world where there's a disaster, earthquake, flood, fire, whatever, and the mobile phone service goes down. And that's a new commercial service launching from SpaceX, thanks to Starlink, in 2024. What else have we got coming up after that? On the 28th, as we said earlier, we've got another Falcon 9 launching Starlinks. Also, the Falcon Heavy launching the Space Force top secret space plane, although everybody knows about it, of course. And tentatively on January the 8th, as we mentioned earlier, we've got the Vulcan Centaur launching the Peregrine lander to the moon as part of NASA's commercial lunar services program. And notable on that lander, which will contain quite a few scientific experiments, if all goes well, one of the experiments to be deposited on the service will be Britain's first moon rover, built by British-Japanese country Spacebit. Or at least we think so. They've gone very, very quiet about it. But the last thing we heard, Britain is going to put a rover on the moon on the first launch of the Vulcan rocket, if all goes well. And that's tentatively scheduled for early in the new year. So we look forward to that. January the 8th is the date it's meant to launch, but it'll be brilliant if Britain does manage to have a rover on the moon, and it's a revolutionary rover, as we mentioned before, because it won't roll across the lunar surface. It will actually walk on jointed legs. It's something completely new from the UK, a new type of vehicle to go across the surface of the moon. And I got really excited about that until I saw what the size of it was. Do you know how big it is, Daz?
It's a little small
it's
thing.
10 centimetres long. So, it's only a tiny thing, but it's a proof of concept more than anything.
Yeah, but if you remember, as I said, when in future, what it'll be doing is it'll be arriving with what you would call sort of like a mothership for it.
Yeah.
It'll roll out, and there'll probably be sort of like 10 or 12 of these little things going out and doing their thing, and then they will come back at the end of the day, download their information, and be recharged.
But it's still great for the UK.
Oh,
it
of course,
how much the UK is moving on in space, and we should all get behind it, basically.
Yeah.
So those are the launches coming up. We'd like to thank you again, viewers, for staying with us this year. We are still looking for people to join the Space Oddities panels. Join us live here on Space Oddities every Tuesday. In particular, we're looking for people who can create content, whether it's presentations, videos, whatever. We would really like to hear from you. If you'd like to join us on the panel and create some content, you must have something that you're passionate about telling the world about in the world of astronomy and space exploration. But we are looking for content creators primarily. So if that's you, if you fancy giving it a go, then drop us a line at spaceodditieslive@gmail.com, and we will look forward very much to hearing from you.
It'll be good. 10 minutes long, 20 minutes long, an hour.
Yeah, that's right. And it can be about any universe-related subject.
The astronomy is just, it's everything, isn't it? So
yes, it's endless. The possibilities are infinite.
I'd just like to answer Ian's question at the end there. No, we won't have planes falling out of the sky or ambulances crashing into each other. I mean, the ambulances should be carrying a decent atlas anyway.
Yeah, that's right. By the way, there's one thing that we have to say to Ian. Happy birthday. It's his birthday.
Oh, yes. Happy birthday.
Happy birthday, Ian. You'll be glad to know we're not going to sing it to you. No. So we'll spare you that. But happy birthday. We hope you've had a great day. And indeed, thank you for joining us on Space Oddities on your birthday. What a fantastic viewer he is. So we should have him stuffed. So there we are. Anyway, fantastic. The space news is a good idea, but needs more viewers. Yes. Now, you may have seen on our channel recently, we've been looping a video of some of the not necessarily the best, but some of the videos that we've been producing in 2023. So if you are interested in becoming a content creator for Space Oddities, have a look at those videos and you'll see the sort of thing that we do. It's been looping for the past several days on the channel. It's a playlist of 10 videos. So if you'd like to join us on Space Oddities and create content, however you do it, then we'd be very interested in talking to you. We can't afford to pay you, I'm afraid, because
we pay ourselves too much for that.
Yeah, we pay ourselves far too much.
Coffee.
So there we are. Anyway, it's time to go, viewers. So have a wonderful Christmas with your friends and family.
Yeah.
We look forward to seeing you back here with us on Space Oddities on Tuesday, January the 2nd. That will be our next show. And from all of us here at Space Oddities,
including live launches.
Yeah, but yes, excluding the possibility of live launches. What was I saying? Yes, so have a fantastic Christmas with your friends and families. Thank you for staying with us this year. From everybody at Space Oddities, not just us three here tonight. We're a bit thin on the ground tonight because it's Christmas. No more needs to be said. So from all of us, have a fantastic Christmas. Happy New Year. And we look forward to...
thank you for the Christmas greetings in the chat.
Yeah, thanks, guys. Thanks.
Yeah, we appreciate you all, Tressa.
We do.
We'd all give you take a virtual hug. Is that a virtual hug? No. There we go. Yeah. Thank you very much. Thank you for staying
malt again, Dad. You've been on the
single malt. Do you think I could afford single malt on the wages you pay me?
Absolutely. Yeah. All right then, guys. From all of us here at Space Oddities, happy Christmas, happy New Year, and we'll see you next year.
Merry Christmas, everyone, and keep